In software engineering, we are talking about software maintenance. Software maintenance. Maintenance means keeping the thing, object, or anything working. That is, the product is already being made. Now you need to clean it, you need to polish it, and you need to keep it running. So this is the last phase of SDLC. All these phases, software is being delivered, deployed, and now the maintenance activity will only start after the delivery. So software maintenance is any kind of change or modification to a software product or a system after it has been delivered to the customer or the end user. This is software maintenance. Please remember, maintenance is the most time-taking and effort-taking task involved in the SDLC. It is being said that change is the only thing which never changes. So change which doesn't change is inevitable. Since maintenance means change, maintenance also is inevitable for any kind of product. I'm not talking about the software product, any kind of product. If you are having an air conditioner, you don't go for the servicing, the filter will get dust and it will be useless after some time. So maintenance is everywhere. Most products need maintenance because they have the wear and tear, like car. Now in the car, say 6 to 8 months you have to get it serviced. There will be some wear and tear in the machinery, basically the tires mainly. And these are the wear and tear, mainly the product or hardware products. But software products, they don't have this kind of problem. That is, they do not need maintenance on this type of count or account. So there will not be a problem like this. Software maintenance has something other to deal with. Many people, they think that if the bad software is created, you need a lot of maintenance. But this is absolutely wrong. The opposite is true. Bad product, what do? You just throw it away. You don't maintain it. But the good products, best products, they are maintained. They have longevity, so they are used for a long time. I'll give an example. See, when Unix came, it was coded or implemented in assembly language. We have known about 8085, 8086, this microprocessor language, etc. Now, when C language came, the Unix was rewritten in C language. Why? Because we wanted to keep working on Unix. So we don't throw it away. This was a good product, so we need to maintain it because it is going for that from the time it was being created till now. Software maintenance takes various types. This can be done in 4 types. Preventive I have written first because this is more related to the hardware stuff. But still, if you are being asked, you have to talk about all these in software maintenance as well. Software maintenance or keeping this software up to date, we need certain maintenance. First is corrective, adaptive, perfective, and preventive. Corrective, adaptive, perfective, preventive. Preventive is the first kind of maintenance because this is the fire cannot happen. Corrective is fire happens, then you do certain thing to get away from it. So corrective maintenance, adaptive maintenance, perfective maintenance, and preventive maintenance, these are the 4 types of the maintenance, software maintenance. Corrective maintenance is all about bug fixing. So corrective means to correct it. That means something is wrong. So if something is wrong, you need to correct it. If you deliver the software to the user, now users start using it. The user observed that, oh, there are certain problems here. So he'll come back to you. He'll say, oh, I'm facing problem here. Now you will fix the bugs. Then, for example, file transfer you have given him. Now the speed you wanted, you are not getting it. You will again go back to the developer and he will say, oh, I need enhancement in the performance. So this is a kind of corrective maintenance. Well, it comes under perfective also, but this corrective maintenance is correction of certain things. What is perfective maintenance? Perfective maintenance is all about enhancements and scalability. That is, user is using. Now he wants, he say, these features are missing. I need these features. Without this, I will not be able to work. So perfective is the new features addition required by the user. Or certain functionality he's using, he's saying, no, it should be on the left, not the right. Or I need to change this functionality. So the customer demands the change in the functionality, and that when you do, that is called as a perfective kind of maintenance. Okay. So it's all about enhancement and scalability in perfective maintenance. Then comes the adaptive maintenance, also called as porting and migration. So the software product needs this porting or migration or adaptive maintenance when customer need the product to run on new platform, on a new operating system. For example, Windows 10 you have, now you have Windows 11. You upgraded your system because it was free and the Microsoft was asking for it. Now certain software are not working on Windows 11. So what do? You will go back to the developer or the company and you'll say, oh, this software is not working. So the software team or the maintenance team, they have to do the adaptive maintenance so that this software work on Windows 11 as well. So new platform, new hardware, new configuration, new operating system, this kind of maintenance is adaptive. Now you have a product. Now you gave the interface for the serial port connection. Now somebody comes and says, no, I want the parallel port also. So these need some interfacing changes. This is adaptive maintenance. And there is a preventive maintenance. See, preventive maintenance is, corrective is, fire has happened. Now you need to say firefight. But here, make the code do something so that fire cannot even happen, cannot even occur. So the way you code, the way you design, you be aware that the maintenance activity should be as least as possible. So preventive maintenance is all about software re-engineering, data restructuring, code restructuring. The effort distribution with respect to maintenance, if you see different type of maintenance, 50% of the maintenance is perfective, 28% of the part is adaptive, and 22% corrective maintenance effort is used. You see here, requirement, design, implementation, testing. What is this part? 67 almost part is your maintenance part. What are the causes for maintenance? What are the reasons? Why do we do the software maintenance? Why it is required? First thing is, while you are developing a software, that is, you have the requirement analysis, then you design, and on the basis of that design, the software is coded. Now the thing is that you are solving a particular problem of a user. Now there is a problem which cannot be foreseen, like Y2K problem. Never people have thought about it, and these kind of problem can come anytime. So if you are not able to anticipate, then during development, when the product is already ready and it is being delivered and this problem comes up, then you need to do the maintenance. Rate of hardware obsolescence. Software never dies. If you take a car, good car, 10, 15, even 50 years, the car is going to die. Car is not immortal because it is hard. It is a hardware. It will succumb to its wear and tear. But software never does. But maintenance is necessary for software performing low-level functions. That is the legacy software, the software which has been made, they are big complex projects, and now it is being used widely. Before 1990, no one ever thought that everyone will be having mobile. After 2020, now we can think that the kids are born with the mobiles, with the cellular phones, the smartphones. So you need to see here that the software needs to be updated, maintained every time. Whenever other software, it works with the change. Okay, let me give you an example. That your software is being delivered. Now you say USB, it will work with USB 2.0. Say USB 3.0, USB 4, 5, 6, 10, say 10 has come. The speed is say 10 Gbps or 100 Gbps. Now it is your liability to change the software to adjust working with this new USB. See, Windows 10, you are always going to Windows 11. It is free update. But what about the software you are working is not working on Windows 11. It was previously working on Windows 10. The software product may need maintenance when the operating system changes. Or user want existing software to run on a new platform. For example, Windows 10 to Windows 11 is a new software, needs new operating system. A new hardware is employed. A new configuration is employed. So if you have 10 functionality, the user can come, he says, oh, 2 more functionality I want. Or the government has changed some scheme or some numbers or interest rate or any other thing. So you need to enhance the feature. So you need to do the maintenance. Like our human beings evolved from chimpanzees or monkeys, etc. We have evolved like this. And we are still evolving. So software is also like that. Software is evolving every time. The time it was conceived till now, it will be in the process of evolution. Every software product continue to evolve after its development. Change is the only thing which never changes. That is, we need to make it evolve through the maintenance efforts for the better. Evolving is making it better for the different environment, configuration, functionality, feature, usage. So there will be some change proposal. There will be some change request always coming from the people or the end user, and you need to change it, make it better. Larger software product, the complex which are being used by numerous people. Now this software was made with immense amount of money. Now it not be viable or feasible to replace it entirely. It will cost more. So better is to maintain it. Like artificial intelligence. Now the Google products have AI involved. But 5-10 years back they were not having that. Still they were popular. Laws of maintenance. So there are certain laws, there are rules for the software maintenance. And what are these maintenance before that? See, there will be a lot of old software. The software which is made today will be old tomorrow. So there will always be a lot of old software that will need maintenance. The user will change, the technology will change, the thought process will change. So the software has to change. And if you have made a good product, it will be maintained, because the bad product will simply be thrown away in the dustbin. So there are certain laws of maintenance. The first one is Lehman's first law. The first law says, see, these laws are very common sense law. But since he has predicted and presented it, they are laws. The first law is software product must change continuously. If they are not changing continuously, they will be useless. That is, they are useful only when the software products are changing continuously, evolving, modifying continuously, and becoming progressively useful. Otherwise, they will be useless. The second law of Lehman says, when software is maintained, its structure degrades, and it always happens. You know the regression testing? Why do we do it? If you hire a maintenance guy and he's not able to maintain properly, if on one part is having a problem bug, he tries to fix it and he creates 10 more bugs. For that, you need to put a lot of effort in the maintenance phenomena, because you really want to avoid this kind of regression or propagating or bug, say, network strategy. Then the Lehman's third law. Over a program's lifetime, its rate of development is approximately constant. There is no peak, there is no trough. Sometimes you are developing a lot, sometimes you are not developing, sometimes you are changing the software, sometimes you are not modifying it. So, right from the requirement, design, coding, testing, deployment, and maintenance, the software development rate of development with time remains constant. Legacy code. There are major maintenance problems. So, what software, what system has already been made years ago, and what are the major maintenance problem we perceive or we encounter? If, first of all, the maintenance engineer, when he sees this code, he finds something. First is the unstructured code. You have bad programs, you have written go to, you have lot of nested if else, multiple if else looping construct. You have big procedures like 1000, 2000, 5000, 100,000 line. So that means bad program. You have very high coupling and low cohesion. So this maintenance programmers, they might not have the knowledge, or they have insufficient knowledge for the maintenance of this sort of system. That is, he might not be having enough knowledge of the application domain. So software maintenance, as the name has grown, evolved, it has taken a bad name. Maintenance means you have a problem, then only you do the maintenance. So software maintenance is like having a bad image. Sometimes a good software means, always a good software means you have good work products like the software product, but not only the code or the source code, you have the documents as well, like the software requirement specification, design document with all the UMLs, test plan, user manual, the installation guide, the compilation guide. There are so many documents which will help the coder and the maintainer. But sometimes the document is absent, out of date, or even insufficient for anybody to actually understand. Even if a very good maintenance guy you have hired, you will not be able to find anything to do. So I will show you these all. I'm just giving you a hint here. There is go to here. This is very bad modularization, low cohesion, high coupling. We are always going for high cohesion and low coupling. And then we have nested if else. The person is going to fall through his mind when he sees it. Insufficient knowledge, bad image of maintenance. That is, the maintenance guy may not be good, or if he is good, then the software he is going to maintain is not good in terms of the documentation, in terms of the content he need to understand. So maintenance team is usually different from the development team, not always, but most of the time. You will always see, oh, the guy has gone to America. Why? He's maintaining the software. He has gone to the offshore to maintain the software. So there is a different team. Even after reading all the documents, sometimes it is very difficult to understand that thing is done in which way, in certain way, because they have not created the software. They are just trying to understand the software. What was the intent of those people who have actually made it? There is one more thing. It is a human, say, limitation. If I read a book, I am talking about myself, I start reading, I just sleep. So if you are being provided those documents and if you start reading, may not be possible you will extract each and every information. So maintainers may be very good in writing code. They are very good at programming. But problem is they may not be good in understanding some code which is written even by other person. You can write code, understand it, make any code. How about knowing the code from others? Detecting the problem, where it is, the bugs, the modifying the design, code or the documentation is again very difficult by a second person. And the most important part, which comes as an interpersonal skill, working with the end user, trying to understand, trying to solve. This cannot be a cup of tea for everyone. So working with end user is also a hurdle. Maintenance nightmares. These are the things which will always be there and giving nightmares to the maintainers. First is the use of go-tos. This is a simple code. You see it is written in BASIC. One more code in C. So you have a go-to. Now previously when it came go-to, everyone was thrilled. Oh my God, what a looping construct. Oh, this has solved a lot of problem. But it has created a lot of problem. This is a go-to. It just shifts the program control to anywhere. Even a big aircraft succumbed to this problem and many people died. That is why in MISRA standard, they say no go-to at all. Then the procedures. We are thrilled to write a long code. Oh, I written this much of code, but they are like the procedure. What about modularization? What about the cohesion? So procedure should be small, should be maintainable, should be testable. Poor and inconsistent naming. Now you just write name like you make your emails earlier. My cracking Insta story like this. This is the name of your variable. We have seen these kind of names. Function is of add. Now you are writing your say your FB peak. These kind of name are used normally. So poor and inconsistent naming is one of the nightmare. Poor module structure. Module structure and even the interdependence network of the modules. These are the key problem in designing. So weak cohesion and high coupling. See, when you are making modules, see here you have different modules and they have a weak cohesion. They are not doing a single work. They are actually taking work from different module, giving them, taking them. So there is high coupling also. But here, a good modularization, good program structure or module structure means a module should do what it was intended to do, single work. That is, we need high cohesion. High cohesion we want. Normally we find weak cohesion. When multiple modules are interacting with each other, we need low or least possible interaction. That is called the low coupling, but we find high coupling. Deeply nested conditional loops. We have a lot of conditional statement, if else, for, while, do while. Go-to is almost finished now. So these are there. So when we program, we tend to put all our logic, mind, brain in making this kind of structure. What will happen? The mind will fall like this, the person is falling here. Functions having side effects. We create functions which are meant for good, made for good, but they are actually creating side effects. They are actually creating trouble in other codes, other functions. How to do better maintenance? Now this we'll talk in the later discussion. And then thank you so much. Take care of yourself.